A dilation is a transformation that changes the size of an image. And that's what we're going to focus on today. We know that translations slide, reflections flip, rotations turn, and dilations dilate. Kind of like when you get your eyes dilated, how your pupils grow really big. So it's a transformation that changes the size of the figure. Now, what that means is this is not an isometry. So we talked about isometries, that an isometry maintains size and shape. So translations, rotations, reflections, they all make the shape stay the same size, even though it may be oriented differently. But a dilation grows or shrinks it, and so it does change size. So a dilation is not an isometry. The scale factor is what is the multiplier. It is what measures how large or how small it grows. Okay, so it's what measures our growth, or what says how big or how small it's going to be. So a scale factor that is either K or N, whichever one it is, a scale factor that is greater than 1 is an enlargement. Okay, so 1.1, 2, 3, any one of those numbers would give an enlargement. When your multiplier is bigger than 1, it's going to make the shape larger. When your number is smaller than 1 but bigger than 0, so if it is bigger than 0 but smaller than 1, then it's going to be a reduction. It's going to be smaller. We've already talked about that dilations are not isometries and why. So let's look, find the scale factor and state whether the image is a reduction or an enlargement. The easiest thing to do is to find the ones that you can count. Find the sides that you can count. So we want to look for vertical and horizontal. That's the easiest thing. So let's say, for instance, we chose this one. So this side is 3. And we want to find its corresponding side, which side that it goes with. So this is the side that matches. It's the right side of the house, and it is 1. Now we went from the red house to the blue house. So sometimes it's hard to remember which way to go, which one to put, new over old or old over new. So here are your two choices, basically. You've got 1/3 and you got 3 over 1, which is 3. And look at what happened since it got bigger, because the arrow points the direction of this in this particular case. I know that it got bigger, which means that my scale factor had to be 3 because it was an enlargement. So when you can't remember which one you're supposed to do, it's supposed to be new over old. The new measurement over the old measurement, and then reduced. You reduce that fraction. That's your scale factor. But when you can't remember, look at them both and use what you know about reductions and enlargements. So if you look at this scale factor, we've got that hypotenuse, but let's not use that. Let's use this vertical side and its matching vertical side, AB. Now remember, A, B, and C, that's our pre-image. A prime, B prime, C prime, that is our image. A changed is how you can look at that A prime. It's A changed. So again, we have 1, 2, 3, 4. That's 4, and that's 2. So it's either 2 over 4 or it's 4 over 2. 2 over 4 is 1/2, and 4 over 2 is 2 over 1, or 2. Now, I know that it went from the purple to the blue, so it shrunk. It was a reduction, so it has to be 1/2. And again, it's new over old. My new measurement was 2. My old measurement was 4. So if you can remember that, you can go straight to it. But I'm just trying to give you tools in case you can't. In dilation, CP prime equals 4 and CP is equal to 20. Those are our corresponding sides. Tell whether the dilation is a reduction or enlargement and find its scale factor. Again, it is new, which is 4, over old, which is 20. Okay, you can see that it shrunk. It went from being 20 to being 4, so it has to be a reduction. You can see that. So it's 4 over 20, which reduces to 1 over 5. Now again, if you can't remember which one it is, test them both, 4 over 20 and 20 over 4. Well, 4 over 20 is 1 over 5. 20 over 4 is 5 over 1. 5 over 1 would have to be an enlargement. 1 over 5 would have to be a reduction, and we know that it got smaller because it went from being 20 to being 4, because this is my new shape. Remember your CP prime, that's your image. That's after the change. So let's look at these on this chart. My original point, so this is how we deal with it when it's on a grid. So my original point was at 5, 2, and I'm going to send it through a scale factor of 3. So my pre-image was at 5, 2, then my image is going to be at 5 times 3 and 2 times 3. So my new image is going to be at 15, 6. So here's the rule. XY becomes KX and KY. The multiplier times X and the multiplier times Y. So it's at 15, 6. Obviously, it got bigger, and we also know that the scale factor is bigger than 1, so it is enlarged. Okay. We look at B. B is negative 4, 12. I want to apply a scale factor, a multiplier of 1/4. So 1/4 times negative 4 is negative 1, and 1/4 times 12 is 3. If you need to, type that in on a calculator. Or negative 4 divided by 4, that's the same as multiplying by 1/4. So I went from negative 4, 12 to negative 1, 3, and that is a reduction. I know that it's a reduction because of the scale factor being less than 1. So I have C is 1/2, and I'm multiplying by a scale factor of 5. So my scale factor of 5, so 5 times 1/2, so 5 times 1/2 is 5 over 2, or 2.5, and 5 times 10 is 50. And that is an enlargement. And then 0.75, I already know without looking, without doing anything else, it's going to be a reduction, because it is 0.75, which is less than 1. So 0.25 times 0.75 is 0.1875, and 0.75 times 4 is 3. You can just do that on the calculator, and that's where your new point goes. So now we're going to use that to apply to this, and you can graph it, and we'll show you. Let me show you this first one. E is at negative 2, negative 2. F is at negative 2, 4. G is at 2, 4. And H is at 2, negative 2. So we've got this original rectangle, and I just want to show you what happens when you put this on a grid. You don't have to, this can be done without. So if I'm going to apply this R factor, remember that my rule is that you multiply the X and the Y by its new factor. So it would be 0.5 times negative 2. So E prime is going to be negative 2 times 0.5, which is negative 1, and negative 2 times 0.5, which is negative 1. So my new E is at negative 1, 1. So there's my E prime. F, you're going to multiply both of those numbers, negative 2 and 4, by 1/2, so you get negative 1, 2. So F is at negative 1, 2. There's my F prime. G, you multiply the 1/2 times 2 and 4, so you get 1, 2. That's my new G. And then H, my new H, is 2 times 1/2. And negative 2 times 1/2, which is 1, negative 1. So here is my E, F, G, and H prime, and you can see that it is half as big. Now, one of the things that is interesting, we are always going to dilate through 0, 0, but when you dilate through 0, 0, if you notice, look what happens to these points. See, they line up. They line up through those 2 points. And that's what always happens with dilations, is they're always going to line up. And if you notice, again, this is just a quick little note. Notice I go up 2 over 1 to get to G, and up 2 over 1 to get to G prime, and then another 2. Notice that I have 2 stair steps. Okay, and so if I go down, I had 2 stair steps to my original figure, half of that would be 1 stair step. So that's just interesting. You don't have to know that, but that will always happen when you dilate through a point. So let's look at another one where the multiplier is an enlargement. I can tell it's an enlargement because it's going to be 2. So again, you don't have to graph it if you don't want to, unless you're asked to pick the graph, which you should be able to tell it's an enlargement. Okay, and like we did at the very beginning, just pick your sides. So my A prime would be -2 times 2, so it'll be -4, -4. My B prime will be -1 times 2 and 2 times 2. And my C prime will be 2 times 2 and 1 times 2. And that's where my new image is. So 1/3, we would do the same. So A prime, 0 and 0 times 1/3 is still 0. B prime would be 1/3 of 3 and 1/3 of 3. C prime is 1/3 of 6 and 1/3 of 3. D would be 1/3 of 6 and 1/3 of -3. And E would be 1/3 of 3 and 1/3 of -3. And that's where all your new points are. Then 2.5, it doesn't matter that it's a fraction. That's okay. My new A will be at 2 times 2.5, which will be 5. 5 and 5. My new B will be at 3 times 2.5, which is 7.5, and 4 times 2.5, which should be 10. Notice these are all ordered pairs. They need to be written properly. And then 5 times 2.5 is 12.5. And 2 times 2.5, which was 5. So my new figure is at those 3 points. So it really comes down to that x, y, when you're dilating, the rule is that you multiply the x and you multiply the y by the scale factor. And that's how you can figure out where